So design a sequential circuit with two JK flip-flops, one input X here and one output Y. So you are given A of t plus 1 and B of t plus 1 and the output equation Y. There is a problem here. So coming to D flip-flops, so it's quite different. So in case of D flip-flop, so we used to, yeah, in case of D flip-flop, so A of t plus 1, if A of t plus 1 is given, so we can find the inputs. A of t plus 1 is equal to D. So the inputs, finding the inputs in case of D flip-flops is very easy. So when next stage is given, so next stage is like A of t plus 1 is given, so that is equal to D. Next state is equal to D here. So that is nothing but the input here. So what are the inputs will be the outputs here. So hence, so finding the next states when inputs are known with JK flip-flops, sorry, with respect to D flip-flops, or finding the next states when inputs are known with D flip-flops is quite easy because both are vice versa here. But in case of JK flip-flops, so it's quite different. So finding the next stage is completely different, and finding the input is completely different. Okay, so we'll see how we'll find the inputs here, because we need inputs to draw the logic diagram. So if I want to draw the logic diagram, so what I have to do here is, so I have to find the input equations. I have to find the values of JK values. We have two flip-flops here. We have to find two JK values here. Getting my point here? Yes or no? So are you following or silent, Donara?
Yes, sir.
Okay. Yeah. So when A of t plus 1 is known, so here in case of D flip-flop, we don't have any problem because A of t plus 1 is equal to, so the values will be equal to dA and dB. So these values are equal to dA and dB. But here what we have to find out here is it is a JK flip-flop. We have A of t plus 1, we have next stage here. What we have to find out here is we have to find the values of JK. So for JK for this flip-flop, JK values for this flip-flop. So that is what we have to find out here. Okay. So first of all, what we have to do here is, so identify the number of flip-flops needed here. Okay. So identify the first step is identify the number of flip-flops required. Okay, and then inputs and outputs. Okay, so first of all, already we have given like so two JK flip-flops are used here. So two JK flip-flops. We'll name the JK flip-flops as JKA. So JK A flip-flop, and we have another one. So JK B flip-flops. So two flip-flops are identified here. Okay. So next, what we have here, so two JK flip-flops are used. So JK A and JK B here. The inputs to the flip-flops here. So we have inputs to the flip-flops. So what we have to identify here is, so what are the inputs to this flip-flop? So JK A flip-flop will have two inputs. So JK A flip-flop will use two inputs because each JK flip-flop will have two inputs here, JA and KA. Okay, so and JKB flip-flops uses two inputs. Two inputs, JB and KB. Okay, so we have two flip-flops. Two flip-flops will have two inputs here. So JA, KA, and JB and KB here. Okay, and the outputs of the flip-flops. I mean, what are the present states? So present states are nothing but A and B, because we have A of t plus 1 and B of t plus 1. So we have present states as A and B. Okay, so next states are A of t plus 1 and B of t plus 1. Okay, and we are given like the combination input is like we have one input X here, so the external input is X. External input is X here, and output we have one output here. Output Y. So this is a problem given, right? Okay, so there is a problem given. So now what we have to do here is, so we can't draw the diagram because we don't have any flip-flop input equations. Like we don't have the values of JA, KA. So earlier, what will do with the D flip-flops? So we have A of t plus 1 values. So straight away write the values of DA and DB. So straight away what we are going to do, we are drawing the logic diagram. But here we can't draw the logic diagram because we have the values of A of t plus 1 only. We don't have the values of JA and KA or JB and KB here. So what we have to do here is we have to draw the truth table. So we have to draw the state table of this circuit here, and we have to find the values of J and K here. Okay, so we have to find the values of J, K of A flip flop and J, K of B flip flop. So that is what we are going to do right now. Okay, so that is the first case here. And next case is to finding the state table. So state table will have present states. So present state, input. This is a state table what I'm drawing right now. Okay, and we can have next states. Okay, and output. Okay, and so when we know present state and next state, so what we can find? What is the definition of excitation table? So what we have seen in the excitation table? So excitation table, so ఏమేమి ఉంటాయి? So what we'll be having in excitation table? Hello. So please respond. So excitation table ఏమేమి ఉంటాయి? So if you don't respond, I'll stop the class and I'll leave you. Sorry. So this is not like one man show. So I can't proceed. So when you don't respond. So you're not going to respond. So what is that? We'll be having an excitation table.
Q of n plus 1.
So what are this Q of n plus 1? What are those?
Present state and next state, sir.
Present state and next states.
Yeah, in the same but ఏమన్నా నెట్వర్క్ ఇష్యూ ఉందా? ఏమన్నా లేదు కదా? టిఫిన్ లేదా? అంటే ఏమన్నా మిమ్మల్ని ఆన్సర్ చెప్తే ఏమన్నా వెళ్ళేస్తారా? ఏమన్నా ఊర్లో నుంచి, లేకపోతే క్లాస్ లో నుంచి, లేకపోతే ఆన్లైన్ క్లాస్ లో నుంచి? ఇప్పుడే ఎట్లుంటే ఎట్లా? పొద్దున ఇంటర్వ్యూ పోతే నాకు జాబ్ వస్తుంది అంటే మాట్లాడరా మీరు? ఏదన్నా అడిగితే ఆన్సర్ క్వశ్చన్ అడిగితే ఆన్సర్ చెప్పరా? సో కొంచెం రెస్పాన్సివ్ ఉండాలి క్లాస్ అన్నప్పుడు. right? So what we have in the excitation tables, we have the present states q of n and q of n plus 1, or q of t or q of t plus 1. So with the help of this present state and next state, what we are finding? So find out this term. We'll be finding the input equations. We'll be finding the inputs of the flip flops. Yes or no?
Yes, sir.
Okay. In the same way, so what we are going to do? So we have to find the values of JA and KA and JB and KB here. So what we are going to do here is, so we have these values of present state and next states, because we have the equations for next states here, A of t plus 1, and we have the present states like A and B here, and we have the input of X here. We'll substitute these values from 0 0 0 to 1 1 1 in the next state equations. When we know the present state and next state equations with the help of excitation table, so you'll find out the values of J, K values here. Clear? Clear or not? So when we know the present state and next states, so in the case of JK flip-flops, okay, in case of the JK flip-flops, so what we are going to do right now, so what we'll be doing here is, so we'll be finding the flip-flop input equation. So the flip-flop input equations are JK here for one flip-flop, JK for B flip-flop here. So we'll be finding the values of JA, KA and JB and KB with the values of present state and next states here. So what are present states here? A, B here. Next states are A of t plus 1 and B of t plus 1. When A of t plus 1, A and A of t plus 1 are known, so we'll find the values of JK. Clear?
Yes, sir.
Okay. So the next kind of inputs is like flip-flop inputs we have to find out here. Okay. Or I can tell it as a excitation inputs. Okay. So excitation inputs ought to be found out here. So present state is like A, B, input is like X here. So next state is A of t plus 1 and B of t plus 1. And what is output?
Y.
Output is Y. And we have excitation inputs. Excitation inputs are nothing but when we know A and A of t plus 1. So the inputs of JK flip flop is JA, the inputs of JK flip flop is so JA, and other one is KA. Is the value of K, and we'll be having the value of A. Okay, so this is for the first A and A of t plus 1 is known. We'll find the values of JA and KA. Okay, for the second flip flop here, for the second B and B of t plus 1, we can find the values of JB and KB. So here the values of J will be there here, and K. So and the thing is like it's JB, and this is KB. Okay, so this is the outlook here. So this is the outlook of the table. Okay, so this is how the table will be. So present states and inputs, next states and outputs here. So we all know these values. So ABX values, so they should be from 0 0 0 to 111. 0 0 0 1 0 1 0 0 1 1 0, sorry, 1 0 0. So 1 0 1. So 110, 111. So these are the present states and input values. So substitute these values in these equations. So what are those equations? So a of t plus 1 is equal to, so a of t plus 1 is equal to ax plus bx. Okay, so a of t plus 1 is equal to ax plus bx. So what is the a of t plus 1 value here? So substitute the values of ax plus bx here. So all the values are ax plus bx lo em substitute cheste em vastundi manaku. So ax plus bx will be the value of a of t plus 1. So substitute these values. So a value is 0, b value is 0, x value is 0. Okay,
0, sir.
0. And b of t plus 1 is equal to a bar x. So b of t plus 1 is equal to a bar x. So a value of this one. So a is 0 here, 0 bar will be equal to 1. So x is 0. So hence it is equal to 0 here. And what is the value of output? So output is equal to ax bar plus bx bar. So a and b are 0, 0. So hence it will be equal to 0. Okay. So this is a of t plus 1. Okay. So this is a of t plus 1 and this is b of t plus 1 and y is equal to ax bar plus bx bar. Okay. The values are like next one 0, 0, 1. So 0, 0, 1, if I substitute the values of 0, 0, 1 in ax plus bx, I'll get a 0. So this is 0, this is 0 and this is 0 and this is 1 here. So I'll get a 0. And b of t plus 1 is equal to a bar x here. So I'll get a 1 here because a is 0 and x is 1 here. So a bar is 1 and x is equal to 1 here. Okay. And what is the value of output here? So output is equal to x bar plus bx bar. I'll get a 0 and 0, 1, 0. So substitute these values and tell me the values here. So 0 and here is 0 and here I'll get a 1. Okay, and 0, 1, 1. So what happens if I substitute 0, 1, 1? So 0, 1, 1 substitute cheste, it's 0, 1 and 1 and 1 here. So 0 into 1 is a 0 and 1 into 1 is a 1. Okay, so that is the value of this one. So 0, 1, I think this is 1 and b of t plus 1 a bar x here. So a is 0. So a bar will be equal to 1 here. Okay. And y is equal to x bar plus bx bar. It will be equal to 0. Okay. And the next value is so 1, 0, 0. So we'll get the value of a of t plus 1 is 0. B of t plus 1 as 0 here. Okay. And the value of y. What is the value of y? So ax bar plus bx bar here. Okay. So a is 1. So x is 0. So x is 0 అయితే 1 into 1 అవుతుంది. So b is 0 and x is 0. Okay, so hence I'll get a 1 here. So 100 ki output is 1 here. Okay, so next 101. So 101 I'll get a, so 1 here. So it is 1 0. It's a 0 and sorry, 1 into 1 it's a 1 here. So 101 ki, so it's 1 1 and this is 0 and this is 1. So 1 into 1 is a 1 and this is 0 here. Okay, so I'll get a value of 1 here and the next value is 0. The output value is equal to 0 here. Okay, so 110. So 110 I'll get a value of 0 for this, 0 for b of t plus 1. Okay, and 0 for b of t plus 1 and I'll get a value of 1 for a bar x. So a bar x is nothing but x is equal to what is the value of x here? So y is equal to x bar plus bx bar here. So I'll get a value of 1 here. Okay, so 111 I'll get a 1 0 0. So substitute చేయండి, వచ్చిందా ఈ వాల్యూస్ వచ్చినాయా? So take down the values and I think you got those values. So it's just the substitution values of a b x here. Okay.
Yes, sir.
Okay. Now I have to find the values of JA and KA and JB and KB based on the values of A and A of t plus 1 and B and B of t plus 1. Okay. So excitation table of JK flip flop. So what is the excitation table of JK flip flop? So the values of Q of t and Q of t plus 1 are equal to 0, 0. So what are the values of JK? So if it is 0, 1, so 1, 0, 1, 1. So see the excitation table of JK flip flop. So see the excitation table of JK flip flop.
0 don't care, sir.
So 0, 0 అయితే ఏమొస్తుంది మనకు? When present state is 0, next state is 0. So what will get here?
0, sir.
0.
So 0, don't care. So the values of, you can check this truth table here when it is 0, 0. So you can మీరు ఏ దానికి J value is nothing but, so A value is 0 and check the value of A of t plus 1. So when it is A is 0 and A of t plus 1 is 0 here, it is a 0, 0 and the value of JK values, I mean the values of JA and KA will be equal to 0, don't care. Okay, so 0 don't care for 0, 0 here and the present state is 0. Okay, and next state is, so what is next state here? Next state is also equal to 0 here. So what else that I'll get here? I'll again get a
0
0, don't care. And here present state is 0. Okay, and next state is also equal to 0 here. I'll get a 0, don't care. Yes or no? So are you following this? Yeah. And here present state is 0 and next state is 1. So when present state is 0, next state is 1. So what is that we'll get here? So excitation
1
table
don't care, sir.
1, don't care. Fine. Okay. And here present state is 1 and next state is 0. Okay. So present state is 1 and next state is 0. So when present state is 1 and next state is 0, what
Don't
is that?
care 1.
We'll get a don't care of 1 year. Okay, and here present state is 1 and next state is 1 year. So what is that we'll get here?
Don't care 0, sir.
So the excitation table will get output of don't care and 0. Yeah, so 1, 0. So 1, 0 will get a
Don't care
don't
1.
care 1. Okay, and 1, 1 will get a, so don't care 0.
Okay.
Okay. Don't care 0. So this is the values of J, and this is for A flip flop here. And coming to B flip flop here. So coming to the B flip flop. So the value is 0 and it's a 0. So B and B of t plus 1 is a 0, 0. So 0, 0 అయితే ఏమవుతుంది మనకు? So we'll get a 0, don't care. And here 0 and 1. So 0, 1 ante, so 1, don't care. Okay, and 1, 0 ante, 1, 0 ante, don't care 1. Okay, and if it is like 1, 1, so I'll get a don't care 0. Sorry.
0.
Yeah, 1, 1, don't care 0. Okay, and 0, 0, so I'll get a 0,
Don't care.
okay, and next again also it is a 0, 0. So 0, 0 ante I'll get a 0, don't care. Okay, and next one is, so 1, 0. So 1, 0 means I'll get a 1, 0 means I'll get a don't care.
Don't care 1, sir.
And here also, so 1, 0, here I'll get a don't care 1. Okay, so this is the final state table here. Okay, so because we have to design a sequential circuit, we are given like A of t plus 1 and B of t plus 1, and the output value is given. So what we have to find out here is we have to find the values of JK here. So JK of flip flop A and JK of flip flop B. So when I want to find the flip flop input equations, when we know the present state and next state, so we have to find take the help of the excitation table. We have to take the help of the excitation table. Now when we know this present state and next states, so finding the J, K values are easy here. So now what I have to find out with the help of K maps, I have to find the values of JA, I have to find the values of KA, and I'll find the values of JB and KB here. Clear? Yes or no? అర్థమవుతుందా లేదా?
Yeah.
So మనం ఏం చేసాము, we find out the values, right? So we are finding the values of JA, KA and JB, KB. Now I'll take the K maps here. So what I'll do here, I'll take the K maps here. With the help of K maps, what I'll do, so I'll find the equations of JA, KA and JB and KB in terms of present states and inputs here. In terms of the present states and the inputs. So what I can do here is, so I know the values of, why to find the values of JA here. Wait a minute. Okay, so find the values of JA. So I'll be having the values of AB and X here. So 8 possible values, 2, 3, 4. So take down this. So finding the values of JA here. So this is A, BX, 0, 1, 0, 0, 0, 1. So 1, 0, 1, 1. Okay, and what are the values for JA here? So it is 0, 0, 0, 1. So it's a 0, 0, 0, and here it is a 1. Okay, and a 0, 1, 0, 1, 0, 1, 0, 1. Okay, and sorry, so I have to take the values of JA, right? So these values. Okay, so it's a 0, 0, 0, 1, and remaining all are don't cares. Remaining values are all don't cares here. Okay, so what I have to find out is I can group this. So I'll be grouping these values here. Okay, so what is this value here? So JA is equal to, so JA is equal to, what is this value? Tell me the value.
BX, sir.
Yeah,
BX.
it's a value BX. So JA is equal to BX. Okay, so take this value, JA is equal to BX. Now I'll find the values of KA here. Okay, so J is equal to BX here. I'll find the value of KA. First 4 values are don't cares. Next one is 1, 0, 1, 0. So this is 1, 0, and 1, 0. Okay, so 1, 0, and 1, 0. So this is the value of K. Correct, Anna? Yeah. So this is the value of K here. So I can form a quad here. So this 2 and this 2. Yes or no?
Yes,
Okay.
sir.
So K values. So grouping these two columns here. Okay. So we don't have A value because both the rows are selected, and the column values are, so this one and this one. So these two are selected here. So when
X
these two
bar.
are selected, so we have B plus B bar into X bar. Okay. So I'll get a, so K is equal to X bar. K is equal to X bar. Yes or no?
Yes,
Yes,
sir.
sir.
Okay, so we got two values here. So JA is equal to XB and KA is equal to X bar. Okay, next we will go for the JB and KP values. Okay, so JB and KB values here. So JB and KB values, so JB is this value. So 0, 1, and here it is a don't care, 0, 0, don't care. Okay, so this will be the value of JB here. So I can take this value like, so these two. Okay, so this two will give the value of A bar into, so these two columns,
X, sir.
X, sir.
these two, so this two will give a value of X here. So A bar X. Okay, so JB is equal to X A bar or A bar X. Clear?
Yeah, sir.
And next value is, wait a minute. Next value is KB. This is A BX 00 00 01. So 10 11, and it's a 0 and 1 here. So KB value, it is a don't care 1. This is a 0, and don't care 1 and 1. Okay, so don't care 1 and 1. So what is that I'll get here? Uh,
X bar.
so this is the column here. So this is so what is this value here? This is A here.
X2
Okay.
plus
So A value I can take, and we can this coaching code
B
grouping
X
ఏమన్నా.
bar. 1
Hmm?
1 grouping తీసుకోవచ్చు. 1 1.
This one.
Hmm.
So any
B
other
X bar.
possibility? So any other possibility? So we can form a quad. I think we can form this quad, right?
Yes, sir. 1 1 X. Don't care, don't care.
Don't care. So we can form a quad. So when we form this quad, so what is this value here? 0010 ante. So I'll get a plus.
X bar,
X
sir.
bar.
Yeah. So this is a plus X bar. Okay. So these are the four values here. Okay. So these are the four values we got. So when, when we find the state table, so state table draw చేసిన తర్వాత, so these are the simplifications we got after the K maps here. Okay. Now I have to draw the logic diagram here. So if I want to draw the logic diagram, okay. So if I want to draw the logic diagram, so we have to draw the logic diagram because we know these values. So JA, KA, and JB values are known here. So now I'll draw the logic diagram now. Okay. So draw the logic diagram. Okay, logic diagram. So we'll be using two JK flip-flops. Okay, so this is flip-flop A. I'll name it as a JKA. So flip-flop A. And this is flip-flop B. Okay, and JK flip-flop has these inputs. It will be having J input, K input. Okay, and here also. So JB and KB inputs, and outputs are A and B. This is A, and this is B, and this is A bar, and this is B bar. Okay, so this is A here, A bar. Okay, and this is like JA, or I can write it as JK here of the first flip flop. This is J, this is K, and this is J, and this is K, and the inputs should be JA, and this is KA, and JB, and KB, and this is BN, B bar. And what are the values we got here? So we got these values here. So we got these values. So JA is equal to X into B. So J is equal to X into B. So we need an AND gate here. So we have X is one input, and we have X into B, right? So we'll get a B from this flip flop. Okay. So this is given to AND gate. So this is JA. This is JA. Okay. What is KA here? X bar. So KA is equal to X bar here. So take this X here. So give it to an inverter. X bar. Okay. And next, JB is equal to XA bar here. So take the value of JB. So this is JB here. This is X here. And so what is that another value we want here? So the value is A bar. So A bar is, we can take it from here. So give it to another AND gate. So this will be, so JB. And what is the value of KB here? So it is X bar plus A. So we need a OR gate. So we'll get X bar here. X bar, yeah, X bar here. And we need a here. So I'll take the value of A from here. Okay, so this is KB. And we have output here. So what is that output? So we got here, so AX bar plus BX bar. So X bar plus BX bar is nothing but A plus B into X bar. So what we can take here is, so A plus B into X bar. So what is A plus B? So A plus B, where I can take it, the A plus B into X bar. So I'll take the value of A here. Okay. So I'll take the value of B here. So give it to OR gate. So and this value should be given into X bar. So where the value of X bar I can take here. So from this X bar, so కొంచెం నీట్ డ్రా చేసుకోండి. So diagram should be meaningful. This is meaningful here. Okay, so this is X bar and this is A plus B. This is given to AND gate. So this is Z. Clear?
Yes, sir.
Right. So first of all, so what we have done. So we are given a problem of A of t plus 1 and B of t plus 1. After giving A of t plus 1, B of t plus 1, draw the state table. From the state table, we have find the values of ABX and A of t plus 1 and B of t plus 1. And when we know these values, we can find the flip-flop input equations. Our first aim is to find the flip-flop input equations. After finding the flip-flop input equations, draw the logic diagram here. Okay. After drawing the logic diagram, so you can draw the state diagram. Okay. So we can draw the state diagram from the state table. Okay. So how can we draw here? So you can see here, these are the four possible states: 0, 0, 0, 1. So 1, 0, 1, 1. So I can name them as S0, S1, S2, and S3. So these are the four possible states. And X is equal to 0. So when X is equal to 0, it will go to the state S0. So S0 and it will remain in the same state. And what is output here? Output is 0. Output is Y here. Output is 0 here. Okay, and when state is like 0 0, when x is equal to 1, it will go to x0 1. Okay, so when x is equal to 1, it will go to 0 and output is equal to 0 here. When state is 0 1, when x is equal to 0, it will go to the state 0 0 and output is 1 here. Okay, and when the state is 0 1 and input is equal to 1 here, we will go to state 1 1. Okay, and the output is 0. Okay, you are clear with the state diagrams, right? So state diagram ఏమన్నా doubts ఉన్నాయా? So you can draw the state diagram.
No, sir.
So draw the state diagram.
Yes, sir.
Yeah, you're done, right? So this is the problem here. Okay, so when you are given the problem like this, with the help of JK flip-flops, you have to do this. So draw a sequential circuit. The circuit will be given. Okay, so when you are given like A of t plus 1 and B of t plus 1, what you have to find out first here is we have to find the values of JA and KA and JB and KV, because the next state equations are given. When the next state equations are given, in case of the JK flip-flops, we have to find the flip-flop input equations in order to draw the circuit logic diagram. So when we draw the logic diagram, so afterwards we can go for drawing the state diagram. So that is using this state table. Okay, first of all, identify the number of flip-flops required. Afterwards, go for the other things. Okay, so take down this problem. So where flip-flop input equations are given. This is another model. సో ఇక్కడ A of t plus 1 లేదు, మీకు ఇచ్చింది సో JA KA and JB KB values and Z values ఇచ్చారు. Okay, and so what, first of all, you are given the problem like you have to draw the logic diagram of the circuit. So tabulate the state table and next to derive the equations for A and B. So that is A of t plus 1 and B of t plus 1 should be known here. సో కొంచెం ఎలాబరేట్ గా డయాగ్రామ్ ఎట్లా చేస్తారంటే సో కొంచెం ఎలాబరేట్ చేసేయండి, బికాస్ ది ఈక్వేషన్స్ ఆర్ వెరీ లార్జ్ హియర్. Okay, so these are the equations here. So we have two inputs here. So diagram కొంచెం పెద్దదిగా అయ్యింది. Right, like so draw it side by side or ఎట్లా డ్రా చేయండి. సో కొంచెం స్పేస్ ఇచ్చేయండి. So give some space here. So this will be A flip-flop, so B flip-flop. Okay, so JA value is equal to BX plus B bar Y. So BX plus B bar Y ante BX plus B bar Y. So that is the value of JA. Okay, so we need two AND gates, one OR gate. So 2 AND gate. So this will be the output A here. This is A bar, and this is B, and this is B bar, and 2 AND gates. Or gates are given to OR gate. Okay, so Bx plus B bar Y. Okay, so we have B here. You can take the value from B here, and X is given directly. Okay, and next B bar. So this is B bar by, and I can take the value by directly. Sorry, this is B bar Y bar. The problem is B bar Y bar. So give an inverter. Okay, right. So that is JA, and JB is equal to, sorry, KA is equal to B bar XY. So this is JA, and KA is nothing but, so B bar and XY. So it is given to AND gate here. So B bar XY. So B bar, B bar XY bar. So this is B bar here. So there is a value of B bar, and this is X here. Okay, and Y bar is, this is Y bar. So somehow you give the connections in a proper way. Okay, and what are the next values? The values are so JB is A bar X, KB is A plus XY bar. Yes or no? Okay. This is JB is equal to A bar X. So where is A bar? So JB, this is X here. Okay, and KB is A plus XY bar. KB is A plus XY bar. This is A here. So no need of this AND gate here. So A plus XY bar. So XY bar is given to AND gate here. So this is X here. And this is Y bar here is given to AND gate XY bar. And so what is the other value? So it's A plus. So we need A here. Okay, and these two are given to OR gate. So this is KB. So this is how it will be generally. So mid equations batti we draw this call. I think you might have got an idea. So as of now, okay. Yes or no? Are you there? So okay na meeku diagram వేయగలరా? Right?
Yes, sir.
We draw చేయండి.
Yes, sir.
And afterwards tablet the state table. State table will be like this. Okay, how the state table will be. State table, so just like this one. So present states, inputs, next states, and the output. So how many inputs we have here? So we have two inputs and two present states here. Okay, the state table will be like this. Okay, so present states, inputs, next states. So next states, we can, yeah, I'll let you know what is next states. So next states, and we have J, K values and JB, KB values, and we have output, that is Z output, and we have inputs like JA, KA, so JB, KB values. We know the KB values, JA, KB, SJ, KA, and JB, KB values. So what we have to find out here is we have to find the next state. Okay, we have to find the next stage. So and when we know the inputs like JK, okay, so we will find the values of A of t plus 1 and B of t plus 1 with the help of truth table. Okay, so when we know the truth table, so when we know the values of JK, so it is nothing but Q of t plus 1. So we can get the value of Q of t plus 1 in a similar way. So we'll have the values of JA and KA and JB and KB, and we know the values of present state and inputs here. Okay, so present state is A, B, inputs are X comma Y, and we don't know the values of A of t plus 1, B of t plus 1. Okay, we don't know these values. So these values are found out from the values of J, K. Okay, so we know the values of J and K and JB and KB, right? So from these equations, so substitute these values, and so write the values from 0, 0, 0, 0 till 0, 0, 0, 1, and so right up to 4 ones. Okay, so right up to 4 ones and substitute those values of this one. Okay, substitute those values. So change it. They're substituting the values in the equations. So that is what we have to do. So you do that. So I'll just share this. So this is how it will be. సో హియర్ ఏంటంటే మీకు XY వాల్యూస్ ముందర తీసుకున్నారు, తర్వాత తీసుకున్న ఇబ్బంది ఏం లేదు, ముందర తీసుకున్న ఇబ్బంది ఏం లేదు. ఓకే, సో టేక్ దిస్ టేబుల్, జస్ట్ యూ కెన్ సబ్స్టిట్యూట్ దోస్ వాల్యూస్, రైట్? సో సబ్స్టిట్యూట్ చేసుకోవచ్చు కాబట్టి, సో జస్ట్ ఐఎమ్ రైటింగ్ ఇట్ స్ట్రైట్ అవే. So take a note of this. So next I have to find the values of A of t plus 1 and B of t plus 1. So this is so name these values like, so AB XY, this is AB XY. Okay, and we got these values, right? So J, K values are 1 0. So what is the truth table here? So what is the value of so A will get here, what is the values of A will get here? So J, K values 1 0 aithe will get a value of A is equal to 1. When J, K values are 0 0, it's a 0. Okay, when JK values are 0 0 here, I mean it's a 0 when it is nothing but Q of n. So JK values 0 0 is there, we get a value of Q. So Q of n is the previous state. Anything, you just unmute. Who is that? Yeah, thank you. Okay, so these are the values like AB XY, so 0 0 0 to 1 1 1 1 here. Okay, and we know the values of JA, K and JB, KB. Okay, from these values we'll find the values of A of t plus 1 and B of t plus 1. So A plus is nothing but A of t plus 1. So this is A of t plus 1. So with the help of truth table. Okay, and B of t plus 1 is B of t plus 1. So B of B plus is nothing but B of t plus 1. Okay, and 0 0 is the value is Qn here. The Qn is nothing but it is equal to 0, since it is a 0, and 0 0 is nothing but the value of Qn here. The Qn is nothing but, so I mean you write the values accordingly. Okay, so what we'll do, we write the values accordingly and find the K maps here. So we can write like this or in other way also. It's like ikkadana rayandi, so AB XY or XY and AB. So in both ways it's fine. Okay, just I'll send a solution of this. So take a note of this table here. So just for your practice, so what you have to do, you have to practice this one. So this kind of models, when these models are given here. So any doubts in this? Any doubts with
No,
this?
sir.
Yeah. So the solution will be shared. So this is a truth table, but at the same time, so what you have to do here is, so you practice that. Okay, so you practice that. So these kind of problems. So when you practice more and more, so you'll be perfect. Like, so you'll not do any mistakes. Okay, so the mistakes will be less here. So the percentage of mistakes, we can do less number of mistakes here. Okay. So there is a truth table. You can take that. After truth table, so we have to find the equations for a of t plus 1 and b of t plus 1. So this is the value we'll get here. So note down these equations here. This is a of t plus 1 and this is b of t plus 1. So take this truth table and also this diagram and also this simplification. Truth table and this is schema.
Kumar sir.
Yeah. So there is a problem and this is the solution for this. Okay. So this is the using JK flip flops. So this is how we have to deal with the JK flip flops. And T flip flops also will follow the same strategy. So for T flip flops, we'll see tomorrow. Okay. So we'll see the design of using the T flip flops tomorrow. Okay. So T flip flop, most of the times it is used in counters. So we'll know what is a counter and all those things. Okay. So we'll see that tomorrow. So this is the problem related to the JK flip flops. Okay, yesterday class we have seen the design using D flip flops. In this class we have seen the design using the JK flip flops. Okay.
Yes, sir.
Yeah. So I'll be sending the recordings of yesterday and today's recording. I'll send the yesterday's recording now and today's recording within 1 hour, 1 or 2 hours, or in the evening session.
Okay,
Yeah.
sir.
So you can drop your attendance and please be prepared. Actually, this is. I mean, you solve all the problems. I'll be checking your notes when you come to the college. Okay. So in college వచ్చిన తర్వాత notes check చేస్తాను. You just note all these problems. So which are very, very important for you. Right. So thank you and have a nice day.